Thank you so much for watching the latest AI Weekly Update on Henry AI Labs up to the week of July 22nd, 2021. This Notion page containing all the papers that will be covered in this AI Weekly Update is linked in the description of the video. We'll start this week by looking at BlenderBot 2.0, an open source chatbot model from Facebook AI that's integrating two new advances described in two separate papers, building on the original BlenderBot model. These two papers are beyond goldfish memory, extending the model with long-term memory using an abstractive summarization model of the context of the dialogue and multi-turn conversation, and then internet augmented dialogue generation, where the model is going to use a generative model to generate internet search queries to augment its knowledge during having these open domain conversations. So in this blog post, they do a quick overview of the goldfish memory paper and the internet augmented dialogue generation, as well as some demo examples of the chatbot, as well as how to load and use it with the Parle AI framework. So digging into these papers behind BlenderBot 2.0, the first of which is Beyond Goldfish Memory, Long-Term Open Domain Conversation. The idea here is that most of these chatbot datasets generally have 2 to 15 turns. Turns meaning I talk, you talk, I talk, you talk, or human, chatbot, these kinds of data sets. Now the idea is to have these long dialogues, and they describe this really interesting data collection procedure where two crowd workers play these roles, and then they meet again after, say, 6 hours a week to chat again, and then use some of the knowledge from the previous chat session to inform their current chat session. And they build this data set using this called multi-session chat, and then they experiment with some different memory augmented models like retrieval augmented generation or the fusion in decoder architecture, as well as using an abstractive summarization system to compress what has been learned in the dialogue history. So an interesting study on this idea of extending chatbots with long-term memory in order to have these conversations that go longer than 2 to 15 turns. So in the other paper in the BlenderBot 2.0 release is Internet Augmented Dialogue Generation. And this is the idea of being able to use the internet during conversation. So compared to, say, using a Wikipedia snapshot and having some kind of information retrieval component with, say, retrieval augmented generation, or again, the fusion and decoder architecture, something like that, you are now going to use the Bing search API to generate an internet query and then use that to integrate the information, going beyond problems with, say, static language models compared to the dynamic nature of information in the world, and using the internet as a source in these chatbot designs. Google AI also has a paper this week on the use of their Mina chatbot. So they're using the Mina chatbot for a human AI collaborative editor for story writing, and they discuss why the chatbot syntax of having these dialogue multi-turn datasets where you treat editing a paper or document, story, whatever it is, as a multi-turn conversation between the human and the AI assistant as a better interface than using language models. So they discuss how language models might be better at doing tasks like appending text to the end of a paragraph, but overall, as you do things like suggesting rewriting or infilling more generally, the dialogue agent tends to perform better as you have this conversation with the AI assistant. So it's a really interesting paper that describes this interface that they build, this problem of human-computer interaction, HCI, and then overall the use of this Mina chatbot, which is this large-scale chatbot to assist with writing. So back on the topic of language models, we have two interesting papers about the data that's used to train language models. The first of which is hypertext pre-training and prompting of language models. When we have these large web scrapes of text like the C4 corpus, we usually get rid of these HTML tags. But these authors are showing that by keeping these HTML tags, you have salient information in things like the title or, say, class and ID CSS attributes that help you with auto prompting. So prompting is this thing where we try to add this context to an input to help guide the language model's generation. They do things like using the title template to help it do things like abstractive summarization of an article by summarizing it into the title, and they also do classification by overriding the class and ID attributes. And overall, an interesting detail is that they have 23 terabytes of this data, which is an absolutely massive scale of data when they're including these HTML tags. And they do describe getting rid of a lot of the boilerplate code and then how that filters the web pages and all these details about collecting this data for training these language models. So then another paper on this topic of the training data that's used to train language models, these authors note that in the C4 corpus, one 61-word English sentence is repeated over 60,000 times. So this kind of duplicated training data is problematic for the language model. It causes this memorization of these inputs. And so they construct these schemes for having exact matching as well as these hash technique near duplicate examples in order to clean this data, reduce train test overlap as well with reporting the validation perplexity, and overall showing how deduplicating the training data for language models improves the downstream performance of the language models and makes it more efficient to train. Next up, we have turning tables, generating examples from semi-structured tables for endowing language models with reasoning skills. This was my favorite paper from this week because it really breaks down this idea of what does it mean to reason with language. They break down these different kind of symbolic operations like composition, comparison, so you have these date differences or these compositions of facts and so on. So they construct these templates in order to extract training data for reasoning tasks from tables from Wikipedia. So they end up constructing a list of 16 different reasoning skills. They have a curriculum error sampling style strategy of sampling from these different generated training examples, and overall this improves performance over the T5 model. So they're showing that you can generate this kind of data with these templates to account for these reasoning skills, and it does improve performance. And overall I think the paper is really interesting, and I love the use of this curriculum learning, error sampling, and also this momentum sampling, which again, back to the Minecraft paper recently from OpenAI, this idea of this change in learning progress, which is how you use the proxy for curriculum learning, and then overall just the way that they construct training data to overcome this neurosymbolic operation rather than having some kind of separate processing operation like another paper we covered recently on the weekly update series, the database reasoning over text, where you might have to fill out a table with the neural network and then use some kind of symbolic system to aggregate the outputs of the table rather than just generating the data in order to overcome having this two-part system. From the Stanford AI Lab blog, we have a description of the paper, Reasoning with Language Models and Knowledge Graphs for Question Answering. This describes an interesting system to use a language model to encode the question answering context, embed that into a knowledge graph, and then use a graph attention network to answer these multiple choice questions in the Common Sense QA, and I think the other one is Open Book QA, but these two different kinds of multiple choice reasoning, question answering tasks that they're combining knowledge graphs like ConceptNet with pre-trained language models to have this joint embedding space and this joint way of this joint graph for using language model representations with the graph structure of knowledge graphs. The next paper in this AI Weekly Update, and also the last one on the topic of natural language processing, is Flex, Unifying Evaluation for Few-Shot Natural Language Processing. So we've seen few-shot natural language processing thrown around a lot with these prompting papers where you either describe some prompt and then see what it generates. These things like GPT-3's in-context learning where you give it some examples and then you see what it generates, but we don't have this standard unified benchmark for evaluating few-shot natural language processing, like say the Omniglot dataset in computer vision. So Flex is a unification of these different few-shot tasks, defining things like meta training sets, meta validation sets, these kind of ideas of constructing these episodes that are used to train these models, different nuances of few-shot learning and how these apply to natural language processing, and these general paradigms of class transfer. Class transfer is, say, in Omniglot where you learn to you sample, say, 4 different characters to form an alphabet, and then you see a new character and you have to transfer to learn this new class, new type of character quickly. Domain transfer, say you train on news articles and now you're evaluated on scientific papers. Task transfer, what you're doing with the data is totally different. You go from, say, natural language inference to question answering, something like that. And then pre-training transfer, the idea of particularly using one of these pre-trained language models to do the transfer. So a really interesting paper unifying these ideas for few-shot natural language processing and creating a more standard benchmark for these kinds of comparisons in these papers on prompting or adapter layers or these kinds of ideas. Excitingly, this week we have a new paper in Nature describing the AlphaFold 2 system, highly accurate protein structure prediction with AlphaFold, as well as the code that's been used to train this model. So some interesting details from the paper describing this multiple sequence alignment, as well as this structural template search, how these are combined into these attention layers that do this kind of you may call it a multimodal fusion between the structure templates, the structure representation, and the multiple sequence alignment. All these interesting kind of biases, these slight designs in these attention operations, like the way they use this gating operation and so on, and how they design the transformer, this evoformer itself, and then some details like how they use knowledge distillation with the protein data bank to make use of the unlabeled or unexperimentally verified structures from the sequences in the protein data bank data set. So some interesting details about AlphaFold and excitingly the code as well. Similar to the distillation used in AlphaFold 2, the Google AI blog has a new article about semi-supervised learning in action at scale. This is building on the idea of noisy student where you have this teacher that distills to a student network that's larger than the teacher network, and they use noisy data to align the pseudo labels from the teacher with the student network. So they use noise like data augmentation, stochastic path dropout, and these kinds of ideas to form this noisy training for the scaling up of this distillation. So they describe how they use this to improve the Google search engine and how they don't have as much data augmentation for natural language processing yet. So they're using the strategy of just going up and then down, where you increase the size of the student and then you decrease it in the compression technique for distillation to create this compressed model and make use of this unlabeled data for the distillation loop in this student larger teacher distillation process. One of the most exciting ideas in artificial intelligence research is AI generating algorithms and ideas like open-endedness. Jeff Clune has a new keynote talk at the Gecko conference on AI generating algorithms, a unique opportunity for the evolutionary reinforcement learning community, describing ideas like the 3 pillars of AI GAs and some recent work like Go Explore, Poet, and all these really exciting ideas for meta learning, the learning algorithms, the architectures, and generating the environments to learn in themselves. Some really interesting research, and I'm really excited to take apart a few of the key ideas of this later on in the weekly update series. Also on this topic of quality, diversity, and having a population of agents, this paper, Adaptive Agent Populations via Generative Model of Policies, aims to learn a latent space that renders policies for controlling reinforcement learning agents. So instead of having this discrete space of agents, you have one continuous embedding of the policies of all the agents that's used to do control tasks. And they do this with 2 loss functions, this KL divergence between 2 randomly sampled policies from latent vector code similar to generators in, say, generative adversarial networks, and then also having another sampled policy that is trained with the proximal policy optimization in whatever environment is being learned. So a really interesting idea of building on this idea of quality, diversity, and having this population of behaviors or agents. So then another very interesting idea, this kind of idea of meta-learning architectures, meta-learning, the learning algorithms, this kind of general area of thinking about these compression algorithms and maybe these hierarchies. We have recurrent parameter generators. This is where we use a recurrent neural network to generate the parameters of the convolutional filters in convolutional neural networks. So the recurrent neural network, I think it takes in the spatial location or the number of the filter map it's on, and then it generates the parameters for the convolutional filter. Say it's these 3x3 kernels, and then you have the D in, D out, this kind of dimensionality of these convolutional parameters, and then they're being generated with this recurrent neural network. So a really interesting idea, and I'm excited to kind of get deeper into the details of exactly how they do this. The next paper in this AI Weekly Update series is Conservative Objective Models for Effective Offline Model-Based Optimization. So this idea is building on, say, adversarial attacks, and then essentially how model-based planning is an adversarial attack on your model as you look for the best path in your model, and there's going to be some problems in your model. So it's similar to, say, this idea of black box optimization, where you have these evaluations of the expensive function f. You have these f of x's, say you're trying to do neural architecture search or any kind of optimization, and then you want to try to find the optimal x, but your space is kind of weak, so you can't just do gradient ascent optimization as is. So they designed these techniques for having these adversarial example generations for trying to improve on this idea of model-based optimization. And it's overall a really interesting paper, and this kind of research of being able to, say, do this design with these, gradient style optimizations compared to evolutionary search and these black box function evaluations. Overall, I think this is a really interesting area of research, and I'm definitely excited to learn more about this algorithm. Next up, we have an extremely large-scale study that even measures the computation in GPU years, titled Representation Learning for Out-of-Distribution Generalization in Reinforced Learning. So first what they do, I think they train something like 1,100 policies, where they start off by training these beta VAEs on these different distributions, and then you use that representation to facilitate the control policy for these different tasks, which I think are cube pushing and one other task that I don't remember, but this idea of how well, what are the details of this pre-trained representation that impact the downstream performance for reinforced learning control tasks from pixels. Another one of the most interesting areas of developing research in AI and deep learning is multimodal representation learning, where, say, in robotics, we're combining visual inputs with the physical control parameters, or say we're combining vision and language is the most popular one that comes to mind, or things like, say, audio-visual representation learning, and so on, or even ideas like time series data combined with tabular data. So MultiBench, a multi-scale benchmark for multimodal representation learning, is combining a few different domains like effective computing, healthcare, finance, robotics, with different modalities like vision, language, audio, video time series and so on, and then having different valuation benchmarks for combining these different techniques like these fusion algorithms for how we combine the representations for each of the separate modalities. So the driving area of research behind these multimodal designs is the fusion technique, how you're going to combine the image representation with the language representation and so on, and these kinds of ideas. So this paper, Align Before Fuse, Vision and Language Representation Learning with Momentum Distillation, is looking at a new strategy for integrating the contrastive loss between each of the modalities and then using this momentum, this moving average of the parameters and then this knowledge distillation loop to further improve on fusion between vision and language. So currently the most famous vision language models are probably DALL-E and CLIP from OpenAI. So CLIP is trained with this contrastive learning objective where you web scrape images and then you have the captions of the images. And then you have the positives of the image and the caption, and then the captions from other sampled image caption pairs in the image text caption pairs in the batch, and then other images in the batch and so on. So CLIP is trained with this contrastive objective, and this paper is looking at how well these representations from CLIP plug into these vision and language benchmarks compared to other approaches like using feature backbones from, say, object detection models or image classification models. So next up, we have a really exciting advancement from HuggingFace in Spaces. So if you've played around with the HuggingFace Inference API, they have this little widget for how you can put in a mask prompt and then hit generate, and then it has this nice interface for visualizing the outputs of the deep neural network. HuggingFace Spaces is going to be a hosted platform for visualizing all these different kinds of input-outputs inference APIs for deep learning models. So things like animate a sketch, where you upload an anime image and then it renders a sketch, this kind of CycleGAN style transfer kind of thing, and then all these other ideas. They're going to be hosted on HuggingFace Spaces, things like Gradio and Streamlit as these strategies for hosting these apps with the Hugging Face infrastructure. So a really interesting thing to keep an eye on is this Hugging Face Spaces development. Thank you so much for watching this overview of the content covered in this AI Weekly Update up to the week of July 22nd, 2021. Again, there's a Notion link in the description of the video that has the links to all the papers or blog posts or whatever it is that is going to be covered in this upcoming series of videos. So I'm now going to be making a series of videos that do a deep dive into each of these things, some short and some long, and then at the end of it, I'll compile it all into a single AI Weekly Update video. So thanks for watching. Please stay tuned to the rest of the AI Weekly Update series, and please subscribe to Henry AI Labs for more deep learning and AI videos.